Yes, now we can start.
So very good morning to all of you. Before starting with the program, two more small things. Please keep your microphones on mute. Secondly, whatever the questions are there in your mind, you can write down in the chat box. After the presentation, we can discuss with sir. So now I'm starting. So good morning to all once again. Hope you all are safe and healthy. Today, I, Dr. Pooja Jain, on behalf of IIM and Nirvan University, welcome all the dignitaries and participants to the national webinar. We are going to have an engrossed learning session with our keynote speaker on topic energy efficient and environment friendly porous radiant burner for cooking and industrial applications. We are grateful for the gracious presence of Professor and Associate Dean P. Muthukumar Sir from Indian Institute of Technology, Guwahati, Assam. He is eminent personality having in-depth knowledge of professional and personal front. Commands high respect and affection with all levels. To commence with today's program, I would like to present a brief description of IIM and Nirvan University, Jaipur. Our university has been endorsed as one of the most promising universities of Northern India. The university is well known for its excellence in overall development-based education of students to facilitate skill building, entrepreneurship development, and creation of leading professionals with the focus of employability. Our university keep on taking such initiatives for the continuous development of both students and faculties. Here, now I would like to take the opportunity to present a brief profile of our keynote speaker, Professor Muthukumar Sir. He is PhD and from Madras and ME from Bharati Ayya University. He is B from Madras University. Presently, Sir is employed at IIT Guwahati and also had a overseas professional experience with University of South Florida, University of Stuttgart, Germany, and Wichita State University. He has received 19 national and international awards for delivering resourceful contribution globally. In his credit, there are 8 patents, 5 books, 12 chapters, and 264 articles in international journals. Our keynote speaker was a keynote speaker for national and international workshops and conferences with the number of 140. 37 students are taking guidance for PhD and 52 students took guidance for MTech. 20 projects he has completed with different government companies like ONGC, MHRD, Robot Bosch Engineering, Government of India, etc. Sir, is novelty and relevance of the research innovation achieved in porous radiant burner for domestic and commercial LPG cooking application. Before going ahead, we are very much delighted and feel highly encouraged by his presence in the caption webinar. I want to call our Pro-President, Dr. Ravi Goyal Sir at Nirvan University and Chairman at Indian Institute of Material Management, Jaipur. Dr. Ravi Goyal Sir is alumnus of NIT Jaipur and actively working in the leadership role since last 2 decades. He is President and Institute Innovation Council and Honorary Education Chair SHM Regional Council for Green and Eco-Friendly Movement. Rajasthan and Chairman of Award Committee for Engineers Excellence Award by Institute of Engineers Rajasthan State Center. Sir has visited more than 10 countries and he has already written 110 national and international research publication papers. Sir is author of 15 books and he is credited with 7 patents. He has received more than 30 awards. So now I would like to request, sir, please enlighten us with your few words.
Thank you, Dr. Pooja. So good morning, everyone. First of all, on behalf of Indian Institute of Material Management, Jaipur and Nirvan University, I welcome you all in this webinar on very relevant topic. I would like to welcome today's chief guest and keynote speaker, Professor P. Muthu Kumar, Professor and Associate Dean, Department of Mechanical Engineering, IIT Guwahati. Sir, welcome.
Thank you.
I would like to welcome my colleagues of Nirvan University, my fellow colleagues from IIM, Dr. Pooja Jain, moderator of this program, friends connected via social media across the globe. So as far as this IIM is concerned, Indian Institute of Material Management is having around 10,000 members with wide network of 52 branches and 19 chapters of professionals engaged in material management, responsible for planning, sourcing, logistics, and supply chain management. Nirvan University Jaipur is incorporated by Act number 2 of 2017 of Government of Rajasthan, and it is promoted by Nirvan Charitable Trust. At Nirvan University Jaipur, we are running various certificate, diploma, advanced diploma, UG, postgraduate diploma, PG programs, and PhD program in various disciplines as per new education policy. And it is located in the Pink City, Jaipur. So once again, I welcome you all. Thank you.
Thank you, sir. Over to Muthu Kumar, sir.
Yeah, so good morning, everyone. Good morning, good evening, and good afternoon. Because since it is an online talk, so we could expect participants all over the world. So therefore, good morning, good afternoon, good evening to all. And first of all, let me express my sincere thanks to Professor Ravi for your kind invitation, and also Dr. Pooja for your friendly introduction. So I mean, really, I'm happy to be here and share whatever we have done on the, this piece of porous radiant burner. So really, I'm happy to share our knowledge to the global audience. So with this short note, let us begin our presentation. Yeah. I think you have to, enable me for sharing the screen.
Yes, sir. Dr. Jasuja, please.
Sir, please.
Yeah, actually, yeah, you have to enable the participants to share the screen. Then only I can share my screen. Yeah.
Sir, please continue. Now you are co-host of the meeting.
Yeah, it's coming now. Yeah, the screen is visible.
Yes, sir.
Okay. Yeah. So again, once again, good morning, good afternoon, good evening to all the participants. So in this talk, I will be briefing about our recent development. In fact, we have been working in this area for over, decade. So recently, we are in the commercialization of the product what we have developed at IIT Guwahati. So in this short, maybe you can say the discussion, I'm going to briefly explaining about the design development of energy efficient environment friendly porous radiant burner developed here at IIT Guwahati for cooking as well as the industrial application. So before starting the presentation, just I wanted to give you a brief introduction about our institute for the benefit of audience. So we IIT Guwahati located in Guwahati, which is called as the gateway of northeastern states of India. So whichever the northeastern states you want to go, and you have to go via Guwahati. We started 1995 and well established during 2005. And as per the NIRF ranking and different ranking, we are holding 6th and 7th place. And as per the the citation per index, we are #1 in India. And of course, we are sharing our rank with IISc Bangalore. So our campus is located on the river bank of Brahmaputra, and which is supposed to be the one of the largest river in the world, which has of course several names. Our campus is about 700 acre in size. We have 8 engineering and 4 science department, and having about 7,000 odd students, and we have about 500 faculty members. So in addition to the human habitation, we also have several thousands of migratory birds and wildcats and animals, etc. it is the absolutely environment friendly campus. So we are third cleanest campus in India and beautiful among all IITs. So in this picture, you can see here the background. You can see the the misty river Brahmaputra. So this is our campus. Yeah, so let us, to begin with our talk, and just I wanted to give the some introduction about the importance of energy. I think most of you are aware about the Sustainable Development Goals, which is set by the United Nations, which need to be achieved by 2030. Most of the countries have committed to achieve this goal by 2030. There are about 17 sustainable development goals, and you can see here: no poverty, no zero hunger, good health, and quality education, etc., etc. So among these 17 sustainable goal, if you see this one, the goal number 7, that is the energy, providing clean and affordable energy to all the mankinds. Basically, the sustainable development goal number 7 derives the remaining sustainable development goal. That means if you achieve sustainable development goal number 7, then only you can, of course, think about the remaining things. Basically, this is the source of the remaining sustainable development goals. So therefore, most of the countries giving more importance. In fact, you can see the keen, they are taking keen interest on this sustainable development goals. So we also committed to, committed towards this goal. And so when you talk about the energy, so let us see our basic human needs. So food, that is our basic human needs. And second one is the cloth and shelter, which also requires energy, substantial energy. Then the water, if you want to get fresh and purified water, we need to spend energy. And again, air, for getting purified air also, maybe in future, we may have to spend energy for getting purified air. So therefore, the energy, without energy, we cannot get, we cannot obtain any of our basic, human needs. So when you talk about the reliable and sustainable energy for future, so this should be available at any point of time, and it should not create any danger to the population as well as to the environment. And the price should be in acceptable range, and then about the availability, be available for the long term, this one. So these are the important requirement of the, you can say, the future sustainable energy. Fine. So if you see the actual fact, so nearly about 13% of the world population do not have access to the electricity. And the another, the very, the alarming situation is that around 40% of the population do not have access to the clean cooking fuel. Even in India, around 46% of the, in fact, only 46% of the people do have the access to the clean cooking fuel. Remaining 56%, of course, they rely on the fuels like the firewood and even cow dung, etc., which is not healthy. And the another thing is the global CO2 level is, of course, increasing. And if you see the over last 4 decades, there is an exponential increase. So therefore, considering all these aspects, so this is the right time, this is the high time to transform our present hydrocarbon energy economy into the to an economy where we don't have, where we don't pollute the environment. That is possibly the renewable energy or the hydrogen-based energy economy, which of course will be explained at the later. And similarly, whatever the energy requirement needed for the building sector as well as the industrial sector should be, of course, fulfilled by the source which is, of course, less harmful to the environment. So with this the small introduction, let us see how our development, our innovation address this concern. The LPG is the the prime fuel in the cooking sector, and also it has the sizable share in the industry as well. Industry like the the ceramic industry, even in the the, you can say, the process industry, even the pharmaceutical industry, even healthcare industries. Many industries they use LPG, even PNG and CNG. Many, of course, gas being used as a fuel in many of the industries. So we are the second largest consumer of LPG, mainly for the cooking application. And so this cooking, you can say the demand for LPG is increasing steadily at the rate of about 10%, because our government is committed to provide a clean cooking fuel to all the mankind, of course, in India. So as I mentioned earlier, roughly about 50% of the people still do not have access to the clean cooking fuel. So So as per the LPG is concerned, which is like the mixture of the propane and butane, more or less the equal percentage. But however, their share may vary from place to place. And the calorific value is concerned, which is roughly about 45,000 megajoule, and density is near about 1.9 kg per meter cube. And if you see the present situation, nearly we import 50% of our requirement from the other countries, and then we could get only 50% from our own source. So this is again a huge financial burden for India. Just I wanted to make a point here that by 2030, our government is committed to reduce the crude oil import by 10%. So this is our one of our one. So this can be done only by exploring our own resource for the cooking application, or maybe improving the efficiency of the existing cooking device. So this is the one. And now to make the fuel affordable to the the common, maybe the poor man, poor communities, our government has been spending huge amount of money as a subsidy. So maybe just I given just to cite and figure. Recently, maybe in the last year, maybe even in the current year also, we are spending approximately about 32,000 to 35,000 crore per year for subsidizing the LPG fuel. So from the current rate to the rate which can be affordable by the poor public, and even we also have scheme for distributing the LPG freely for the certain class of people. So as a result, our government is spending huge amount of money every year for subsidizing the fuel. Again, the fuel price is fluctuating, and even of course, the 900 rupees is the rate. Just I checked with 15 days back. Maybe I don't know about the present date. Present date maybe slightly, it may be higher. So the result, the price are they were fluctuating to a larger extent. It's mainly because, as I already mentioned, so we are importing nearly about 50% of our requirement from the other countries. So now you see, if you look into the technology, what we have for cooking application, we have, for example, electric stove, induction stove, then LPG, PNG, and biogas. And if you see all of them, and of course, each of the fuel has its own merits and demerits. Maybe if you see the biogas, affordability provided if you have the gobar gas plant at your own place. And so it is, and of course, since I mean, these can be generated free of cost, but the maintenance you have to take care of the maintenance. But if you see the technology wise, the reliability of the technology wise, which may not be so efficient, the available cook device for the biogas are not so efficient, because mainly because of the presence of high amount of CO2 in the biogas. And then the LPG stove, of course, everything is fine, but I mean, this is very expensive now these days, and suddenly which cannot be affordable by the poor class of people. And PNG, and again, it is everything is okay, but again, we don't have the infrastructure, taking this fuel into the rural level. But coming to the electric stove, and see in the environmental, in fact, I have marked as a red. The reason is that, see, as a stove, it won't pollute anything, but you have to see where we are getting the electricity. Suppose if you generate electricity, if you get the electricity from the coal-fired thermal power station, for every 1 kilowatt hour power, the amount of CO2 emitted to the environment is roughly about 1 kg. So currently we have about 230,000 megawatts of power generated from the fossil fuel route. That means every 1 hour we are generating about 230,000 tons of CO2, which is emitted to the environment. So that's why, as per the environmental impact is concerned, all the electrical related appliances are rated in the red color. So these are the device, and you can see the cook stoves available in the market, and most of the cook stove efficiency ranges from 60 to 65%. These are the numbers which is based on the laboratory condition. Maybe when you test these stoves at actual your kitchen, the efficiency may be still lower. And besides having low thermal efficiency, if you look into their emissions, which are very high, for example, the CO varies from 400 to even can go up to about 1000 milligram per meter cube, and NOx also, which is very high. And these values are, much higher than the standard prescribed by the World Health Organization. So therefore, we need to, carefully we need to think about, the redesigning of the device. So basically, these most of the existing cook stove available in the market works on pre-flame combustion, where the LPG is injected through the nozzle, and at the exit of the nozzle, you will experience high velocity, the high velocity creates low pressure. So therefore, through the natural air entrainment, the air enters through the mixing chamber, and it get mixed here, and yeah, it get mixed here. Then after that, it will come to the top of the burner surface, where of course the gas mixtures getting combusted. Then you can see the flame. So this is the typical operating stove. So to establish the performance of the you can say the commercial cooking stove, and we have done the standard water boiling test following the procedure given in BAS 4246 by conducting the water boiling test as well as the emission test. Maybe if you look into this the figure, the efficiency ranges from say 68%, that is when you operate the burner at low power range, that is about 1 kilowatt. And then when you operate at high power rate, maybe at about 3 kilowatt, then you can get roughly about 60%. And this is for the domestic stove. Then if you come to the commercial stove, that is one which is being used in hotels, the hostels and etc., where the power ranges from 5 to 15 kilowatts. And here the efficiency are very low, maybe in the order of about 30% when you operate the burner at say about 15 kilowatt. And besides having low thermal efficiency, you see their emissions are very high in the range of about 300 to even it can go about, to 1,200 ppm, which is much, much higher than the standard prescribed by the World Health Organization. So this is the background. So what, of course, with that, to reduce the fuel consumption and make the device more efficient, and then we introduced the concept of porous medium combustion in the cook stove. So basically, this technology consists of 2 layers of porous matrix, and you can see here the preheating zone, which is made up of ceramic, which is having low thermal conductivity, and then this above one combustion zone, which is made up of highly conducting and radiating ceramic matrix, that is a silicon carbide. Okay, so these matrix will be placed one over the another. So preheating zone will be, that is ceramic matrix will be at the bottom, and above you will have the combustion zone, that is the ceramic one. So when the air fuel mixture is introduced through this matrix, and the combustion happens initiate in between the these 2 layers exactly here. And since the combustion is happening inside the highly conducting and radiating porous matrix, so some portion of the combustion heat will be transferred back to the preheating zone, because the radiation is a multi-dimensional phenomena, which is basically it can happen all the direction. So since it is happening inside the porous matrix, so some part of the combustion heat will be transferred back to the preheating zone for preheating the air fuel mixture. As a result, the air fuel mixture is preheated from ambient temperature to maybe up to about 150 degrees Celsius before it reaches the combustion zone. Since the air is preheated, air fuel mixture is preheated, and it is happening inside the, and again the combustion is happening inside the porous matrix, here you can get the combustion efficiency close to almost 100%. Combustion is 100%. Because of this preheating effect, so you can minimize the surface temperature of the burner well below, you can say 1100 degrees Celsius. So this preheating effect, and as well as minimizing the surface temperature well below 1100 degrees Celsius, and all these things put together and provides the much higher thermal efficiency. And here in our burner, the predominant mode of heat transfer from the surface to the vessel is radiation. As you know, the radiation travels at a speed of light. Whereas in case of the conventional burner, the mode of heat transfer from the flame to the vessel is by convection. So there, the contribution to the contribution of conduction and radiation is negligible. As you know, the gases are having low thermal conductivity and low emissivity. Okay, now you can see here, this is the flame, and the conventional flame, and here you can see the maximum temperature will be experienced at the middle of the flame. Then when you go towards the periphery of the flame, there will be a large temperature gradient, which may be about 300 to 400 degrees Celsius. This large temperature gradient, of course, promotes the formation of thermal NOx. In case of our burner, you see here the temperature. You can see the uniform heat flux. That means the temperature variation along the the radial direction is almost negligible. You will get the uniform temperature distribution. So basically, our burner, is made up of indigenously developed low-cost, material, and here we are not using any metallic part. So the predominant material, the materials are, you can see the burner casing, which is again made up of low cost ceramic or any, you can use the alumina or maybe the combination of alumina. It's basically these are the ceramics. And then the preheating zone, again, it's the alumina matrix. And then combustion zone, here we have the silicon carbide matrix. These all are very, very cheap material. And we are not, of course, using any of the, this one. And again, so though the configuration also, we make it very simple. This is a mixing tube, and here we have the casing, and then just to have a wire mesh to support this one. This is the preheating zone made up of alumina, and here we have the this ceramic. So it's everything, though it's look like simple, but it's not so simple for designing. So the whatever the diameter, thickness, and the porosity being used for this construction, they were carefully selected based on the rigorous thermal and combustion modeling. Even if you try to change the porosity or try to change the thickness, it will not work. It will lead to the danger. So we have designed, and so on. We have given all these things. And so our burners, of course, provide the much safer operation than the existing LPG stove, of course, within our design parameters. So this has been tested across several labs and several hotels and several commercial space, and then people are, of course, very happy about our technology. So now let us see this one, the burner which we have developed for domestic cooking application. Now you can see here. So of course, it's a long journey. This is research initiated during 2000, you can say 6 or 7, and with different stages, we faced several hurdles, and now we are in a position to take our product to the commercial market. And so initially, we achieved efficiency up to about 70 to 75%. With you can say with the regulator available in the with high pressure regulator, and because since as per the BSI requirement, we should not, of course, change the specification of the gas regulator. So therefore we need to go for the regulator which can provide only the 20 to 30 millibar supply pressure. So with that and with the alteration in design, again we achieved thermal efficiency close to about 81%, and against the conventional thermal efficiency of about 60 to 65%. So with this new design, we could get minimum 30% fuel saving. And besides that, we have also done the extensive so-called the control cooking test and kitchen performance test and life cycle assessment test. In all the tests, we got roughly about, on and average, we got 30% fuel saving. And in addition to 30% fuel saving, we also got about minimum 30% save in cook time. This is very, very important. And also our burner, reduces the, you can say the CO NOx emission to up to a large extent, that is up to about 85%. Okay, so now the next step to go for the higher scale, the large capacity, and this is the stove available for commercial cooking, which has very low thermal efficiency in the range of about 30 to 45% maximum, and their emissions are very, very high. So here, of course, we developed a burner for commercial application at different power segment. For instance, the burner which can provide the output in the range of about 5 to 7 kilowatt, showed about efficiency close to about 65% with 45% fuel saving, which is very, very, you can say, significant. And so this burner is already, it's being in operation in few of the hotels in Bangalore and as well as the other place. And here also, of course, we could reduce the CO NOx emission to a larger extent. You can see here, this is the best available commercial burner where the CO emission ranges from 330 to, approximately 550 ppm, whereas our burner, produce only 23 to 38, of course, ppm, and NOx is almost zero here. Okay, then if you want to go for the higher power watt, maybe up to about maybe 10 to 15 kilowatts. So we introduced the concept of clustering the burner. So when you cluster three, you can say domestic burner, maybe slightly higher this one, and you can get the power output in the range of about 15 kilowatts. So these high, the power range burners have its own, niche application in the cooking as well as in the industrial sector. So here we got, efficiency up to about 67% maximum. So this burner yielded fuel saving up to about 60%. Okay, these are the various, can say the stoves developed here, and starting from the commercial, this is 5 to 7 kilowatt. and all the performance test being of course done based on the procedure given in BA standard by conducting the standard water boiling test. And we also followed the ISO protocol also, and the emission is again measured again the Hood method, again the procedure followed in prescribed in BAC standard. Yeah. So okay, so we have also done the so-called the TECO economic assessment. Maybe obviously one can ask if the burner is used in the commercial or maybe domestic kitchen, and what could be the saving. So here what we have done, of course, we have done the systematic analysis, and we have considered a commercial cooking stove available in our hostel, which consumes about 12 kg of LPG per day. And this was taken as a reference, and this test was done nearly about 3 months, and we have performed the cooking both the similar kind of dish in our burner as well as with the conventional burner, and they based on the the savings, the fuel consumption rate observed for about 3 months time. And so we estimated the cost. So the cost cost saving could be anywhere between 40,000 to about 68,000. This is reported in the this one in the hostel for the commercial one. And then even for if you go for the PRB, and actually this number is achieved based on the old efficiency data, and in the recent data we could save nearly about 4,000 rupees for the the domestic application. So the amount saving is very, very huge. And then if you see the cost of this burner, maybe the porous stadium burner for the commercial cooking, maybe maximum maybe about 7 to 8,000 rupees, which includes everything. So whatever the investment you are making, if you look into the cost of saving, your investment can be taken, maybe can be retrieved maybe within about a couple of weeks, not more than that. So that's how this so-called the life cycle assessment, has been done. So I think these are the standard protocol, which is of course followed by the several researchers. And this is another interesting thing. It might be interesting for the maybe the woman can say the audience. So we have done the so-called the control cooking test, and we have taken the national average menu. And these menus, of course, these menus are prepared based on the family consisting of 4 adults. And so you can see here the menu A consists of dishes like rice, pulse, vegetables, chicken, leaf bread, milk, tea, and etc. And then you can see here this is the porous stadium burner and the conventional burner. We prepared these dishes side by side, and if you see the summary, our burner consumed about 200 grams of LPG and took about 115 minutes, whereas the conventional burner consumes roughly about 300 grams of LPG, and it took nearly about 166 minutes. So you can see here the fuel saving is more than 30%, and as well as you can also see the time also you can save nearly about 60 minutes. This is for the menu A, and similarly we have the menu B. Here we have the rice, dal, vegetables, fish, and fried, and milk, and etc. Here also almost the similar pattern of saving, has been observed for for menu B also, and similarly for menu C also you can see more or less the similar savings. So therefore, in whatever this actually the saving time it's mainly because of the better cooking. In sense, the better cooking can be obtained by the effective transfer of heat from the burner surface to the vessel. So in case of on our burner, so it's a combination of the radiation is the predominant mode of heat transfer. In addition to the radiation, there will be also conduction. Okay, there will be also conduction. So because of the combined, the mode of heat transfer, here we could get minimum heat loss, of course. Whereas in case of the conventional burner, the predominant mode of heat transfer from the burner surface to the flame to the vessel is by convection. Okay, so then we have also done extensive work on kerosene stove also. Still, kerosene stove is prevailing in India. Mostly these stoves are used by the migrant laborers, and though our government is not encouraging the use of kerosene, but still, people are some class of people are using kerosene. So here also we have introduced the concept of porous stadium burner, and you can see here there is a direct fuel saving above saving of about 30%. I mean 20 to 25% here we got. And besides having higher thermal efficiency, here also we reduced the the CO NOx emission to a larger extent. Okay, so then this waste cooking oil. I mean this is the disposal of waste cooking oil is a major challenge. What happens in the big hotel industry? They sell this waste cooking oil to a vendor. These vendors, they get the waste cooking oil and they sell it to the street foodies. And these people use the oil used by the many people, and then finally end up with having several health issues. Actually, the waste cooking oil that should be supposed to be disposed, we can use either for burning application or maybe for some other application, and it should not be used reused again for cooking. I mean, there are protocol, but the countries like Europe and the US, they are strictly. We don't have any protocol. As a result, we end up with several issues. So we, of course, we try to use this waste cooking oil for the cooking application. What we got done, we of course mixed it with the kerosene, and we have prepared several blends. So the blend of about 50% waste cooking oil and with 50% kerosene. With this blend, we could get at least the better combustion. So when we operate the we have prepared several blends. The blend one is 10% waste cooking oil and 90% kerosene, and the blend two is 50% waste cooking oil and you can say the 50% kerosene. So with this range, so 10 to 50% range, we could get the stable combustion. So this fuel has been tested both with the conventional as well as the porous styrene burner based one. So when you go for the porous styrene burner, here also we could get about 25 to 30% more efficiency. So another one is the porous styrene burner, of course, developed for biogas. As I already mentioned in the beginning, because the porous biogas gas is not being promoted much for cooking application because of the lack of, you can say, the efficient, you can say, the burner. So that issue has been addressed here. Now you can see here. So this is the burner what we got developed for biogas. Now it is in burning, and you can see the very beautiful, of course, the burner surface without any flame. So here, I mean, the technology, we can get about 30% fuel saving, and also we could reduce the CO NOx emission to a larger extent. And so therefore, now with this introduction of this porous styrene burner, hopefully there will be the major shift in the biogas utilization as well. Okay, so and now you can see here, this is the biogas. It is again for the industrial application. You can see here, it's a bigger burner. Can you able to see the white wave? That is white wave, some wave. That is basically those are the radiation wave. Yeah. So this is the cluster burner. So this can be used for many hotel industry or for the bakery or in the steel industry. You can use it. You can use for them for any application where you need the power range of maybe about 10 to of course 20 kilowatt. And this is again used in one hotel. This is again just we are testing it. Even actually, if you want, we can also have the partially pre-mixed, partial pre-mixed flame. Also, we can design the burner for some application. The partial pre-mixed burner, like the burner what you are showing, seems to be the better option. So this kind of burner. So like particularly if you use this kind of a kadai curved vessel, so this kind of burners gives the better efficiency than the completely submerged combustion. So of course, our burner is being explored not only for cooking, and now we are exploring for several industrial applications. This is one for the industrial drying. So here, of course, you can get about straight away 30 to 40% fuel saving. And this is another the burner designed for the ceramic industry. and as well as the cremation and several, the waste, biomedical waste disposal. So wherever, we have the thermal management or the, furnace, this application, our burner can be effectively used. And anyway, this I will discuss with you. This is about the waste cooking oil, and those things are given here. And so our burner, the technology, the porous medium technology developed at IIT Guwahati, being of course published in several, almost all leading, the news magazines, and which is highly recognized. And so this burner secured the, of course, the one of the best, the project among 250 to 100 projects from the government of India through the imprint scheme. And this is, you can say, the secured in the top 15 place. And again, in the top 15 place, this was ranked, number one. And so this technology has been tweeted by the, several celebrities like the ex Ministry of Higher Education and EST and AICT, many, of course, this one. And so now currently we are trying to use our technology for several applications, including the face heating, particularly in the high altitude region. Our Indian Army camp, they use the kerosene for the face heating application. Currently they are using, you can say, the big stoves. And so when these stoves kept inside the room, and this produce so much of smoke, and they cannot keep the stove inside the room for more than 10 minutes because of the suffocation, and they have to keep it out. And there are issues, and because in the high altitude region you cannot use LPG, because the LPG, it won't, of course, vaporize such a very low temperature. So they have to go for only the liquid fuel, especially kerosene. So we proposed the so-called the porous radiant burner equipped with the heat pipe technology. So the heat produced from the porous radiant burner will be transferred to the room through the heat pipe technology. This is one of the ongoing project with the Indian Army. So we also now developed the so-called the biomedical waste incinerator for this, you can say, the handling the biomedical waste or any municipal waste or anything. It can be handled easily with our this incinerator. And now we are developing the so-called the cremation unit with the help of this technology. So with this technology, you can cremate any body, particularly the COVID infected body can be easily cremated just by consuming only 20 kg of LPG or even less. So this will save a huge amount of energy, and as well as this also protect, of course, our environment. So recently, our government of India is promoting methanol as a cooking fuel. As an alternative to LPG. As I already told you, our government mandate is to reduce the crude oil import by 10% in 2030. So that is our mandate. So the Niti Aayog is taking seriously, towards this one. They are taking several measures towards this one. And so this, the use, the methanol as a use of methanol as a cook fuel for as a fuel for cooking application has been proposed last year, and then the task was given to me for drafting the BA standard. So we got drafted the BA standard, and which is, of course, in the final stage. Maybe hopefully it will be published in about 10-15 days. So this methanol, there are, of course, several roadmap. Maybe in about a year, our government is planning to launch about 1 crore stove in the market, and maybe in the subsequently this number will be increased. So the methanol is, of course, projected to produce from the the locally available resource at a rate of about 14 rupees per liter. So 1 kg of LPG will be equivalent to about 2.2 liter of methanol in terms of calorific value. So that is the plan. So once this methanol is promoted as a fuel for this one, definitely the dependency on the LPG will come down. Particularly, this will play a major role in the rural sector. So here, of course, we have done systematic investigation, and we have optimized and designed this stove carefully to meet our Indian requirement. So here we got about roughly about 55 to the 65% thermal efficiency, which is much higher than the numbers available globally. This one. And see, actually, the problem is these are the canisters. These canisters, can take about 1.8 liters of methanol. So once this can serve maybe about 4 to 5 hours. So once you after burning about 4 to 5 hours, then you have to take out the canister and again you have to go for refilling. So this is a real challenge. So because the methanol cannot be like the similar to the conventional pressurized stove, and methanol cannot be operated because there are issues with the methanol. Methanol is having high burning velocity, and methanol cannot be combusted like as a kerosene in case of the stove. There are several issues. So therefore, the only way for using methanol as a cook oil is in the form of canister. But the canister is having the issue. So every 4 hours you have to change the canister. Then you have to go for refilling. So this is a real challenge. So what we have done now, so we again we extended our technology, porous stadium burner technology, for developing this this stove. So you can see here. So with this porous stadium burner, so with our this technology, we could of course successfully operate the burner with methanol. And so here we got of course close to about 67% thermal efficiency, which is much higher than the canister one what we got shown earlier. And here also we reduced the CO NOx emissions. So the BA standard for canister based methanol stove, this stove is already available. Maybe it will be available to the public maybe in about a couple of weeks. And soon we are also going to get BA standard for the the porous stadium burner as well with methanol. So therefore, so this technology, so now the technology is already transferred to the industrial partner, and we are in the process of course, commercialize, taking this technology to the commercial market. Maybe in about another 3-4 months, we can find our stove in the commercial market. Because of the COVID, there was a delay. So on an average, our stove can save nearly about 3 to 4 kg of LPG per cylinder. Currently, our consumption rate is roughly about 45 lakhs to about 50 lakhs cylinder per day. So if you see this saving, even if you take the minimum saving of about 30%, and the amount of money saved for the government of India is roughly about 45,000 crore per year. And in case of the industrial cooking, and here we can get huge amount of saving, about 6 to 7 kg of LPG. And even biogas and kerosene, any stove, even we are also going to try with the fuel like dimethyl ether and methane and all these things. So any fuel, our burner can be operated in any fuel. So wherever you use our technology, you will get minimum 30% fuel saving. So with this fuel saving, if you consider the consumption, overall consumption of LPG or BNG or CNG, any fuel, both in industrial and domestic sector, the amount of money saved by the government will be very huge. And in addition to money saving, and if you see the other indirect saving in terms of CO NOx, that will be of course very huge. Okay, so that's all about this porous stadium burner. So maybe I thank everyone. So if you have time, maybe I can also give maybe another 10-15 minutes talk about hydrogen energy.
Sir, please go ahead. This is a very interesting session. Please go ahead.
Okay. So anyway, just maybe another 10-15 minutes about the hydrogen economy. This is another very important topic where our government is focusing. So this is our today's hydrocarbon energy economy. So what we are doing now during the exploration of the hydrocarbon, which may be a coal or maybe fossil fuel or crude oil, whatever may be, during the exploration and transportation and storage, all the three means like the water, air, and land are getting polluted. And during combustion of this fuel, we are taking green oxygen from the environment, and what we are giving back? We are giving back all the, you can say harmful, you can say the emissions like CO2, NOx, and etc. So as a result, the environment is getting polluted day by day. That is the present energy scenario. So as you know, we spend nearly about 50% of our revenue for importing the crude oil from the the other countries. So as per the energy is concerned, we are not energy independent. That's why the government is planning, exploring all possible alternate ways to cut out the crude oil import. So this is our present energy scenario. I think roughly recent figure may be close to about 390,000 megawatt of power, and majorly we are getting from the thermal route, that is the coal-fired thermal route. Roughly we are getting roughly about 62% of power we are generating from the thermal route, which includes the coal, lignite, and gas, and etc. That's what initially I told, because all this the power generating sectors emits roughly about 240,000 tons of CO2 per hour. Okay, which is which is very harmful to the environment. And as per the renewable is concerned, our share is close to about 33%, which is much higher than the world average. So, which is really interesting things. So, if you see the last couple of years, so we are not encouraging the power generation from the thermal route, that is the coal-fired thermal route, as you know, the mainly because of the emission. And hydro, I mean, it's increased by about 15% last year. I mean, if you compare the last 2 years, and nuclear is, increased because since the nuclear capacity is very low, even if you add some few kilowatt and megawatt, so the percentage will be high. And renewable is mostly we are promoting in the PV. Renewable is increased by about 9%. Actually, this increases with reference to their figure in the previous year. The overall energy growth rate is roughly about 1%. So as per this is the current renewable share, about 36%. Major is from the hydro and followed by solar and wind. And so if you see compare the three major resource for the energy resource, that is fossil fuel, renewables, and nuclear. As per the fossil fuel is concerned, it's very safety and technology is reliable technology. As per the coal availability is concerned, it can be available for another maybe available for another 300 odd years. But the major issue here is the CO2 emission. Then coming to the nuclear, and so safety is high and cost is moderate, unlimited. But here there is a issue, there is waste disposal, which of course there are a lot of course debate on it, because I don't want to get into this controversial topic. So let's see the renewables. In the renewables, if you see this one, it's environmentally clean and safety is very high. Here there is no moving, absolutely there is no the process or components which is polluting to the environment, and which is very safe. And cost right now, and the cost of the solar PVs has reduced to a larger extent without storage. And there are schemes available, and if you go through any one of these schemes, and you can get the power, I mean 1 unit of power generator from the PV in the range of about 2 rupees 30 paise to 2 rupees 50 paise, against the conventional power cost maybe around 5 to 7 rupees per unit. So this is, it's a very thing, and that's why this is picking up very fast. So the solar energy, of course, in solar, we can generate power in through two routes, photovoltaic and thermal. In photovoltaic, here the sunlight is converted to electricity through the photoelectric effect. Here the conversion efficiency anywhere between 6 to 18%. The cost already I have told you 2.5 to 7. This very, it depends upon the location, but the issue here is the storage. When you go for storage, the overall cost, levelized cost will increase. It can go up to 12 rupees. So the storage is the key issue in case of the solar PV is concerned. Coming to the solar thermal, here conversion efficiency can be up to about 35%. And cost, if you are not going for thermal storage, cost is little high. But if you go for storage, the cost will reduce maybe up to even below 5 rupees. Okay, so the application as per the solar PV is concerned, we have plenty of application, and this I don't want to discuss. Again, solar thermal also has several applications, including solar, the power generation, paste heating, water heating, drying, cooking, and etc. There are numerous applications. Solar thermal is concerned. Okay, so that's how this you can see this. It's a very beautiful figure here. About the energy transition. So in the 18th century, we used wood as a major, the source of energy, which contains about 10 carbon atoms per hydrogen atoms. Then because of the high carbon, we moved to coal, which has only 2 carbon atoms per hydrogen atoms. Then we moved towards oil, and we are further reduced, and gas, which contains only 0.25 carbon atoms per hydrogen atoms. And ultimately, we are moving towards hydrogen, which has, of course, no carbon atoms. That's how the energy, of course, the transition occur in near future also. So let us see what I mean. The earlier I have presented the figure which is based on the hydrocarbon economy. Now the same cycle I am converting into hydrogen. So let us assume we are generating hydrogen from the renewable source, which may be solar PV, or maybe wind, or maybe hydro, or even maybe nuclear. For generating the hydrogen, we need water, which is the raw material, which can be taken from the environment. And when you spill the the water, and you will get oxygen as a byproduct, that you leave it to the environment and take hydrogen, only hydrogen, to the combustion device. And where we need oxygen, so whatever the oxygen which is emitted during the generation, that can be taken from the environment for combustion. Okay, so then during combustion, your byproduct is water. So whatever the amount of water taken from the environment, and the same water is given back to the environment. So if you look into the cycle is, it's a complete, and nothing is taken from the environment or left to the environment. So basically here hydrogen is acting as an energy carrier like electricity for transferring the energy which is available in the form of renewable energy source to the user. So therefore the cycle is absolutely safe and reliable and sustainable. So that is the cycle what we are looking for in the future. So again, it is in the different form. Water is a raw material and use the any one of the primary source which is non-polluting in nature and produce hydrogen and use it in any one of these application, and which is from the transport sector, domestic sector, and industry sector, and etc. And ultimately you will end up with water as a byproduct, as a end product. And again, the same water can be taken up. Okay, so as per the automobile application is concerned, the hydrogen, this is a major debate. The storage is the key issue, since the 1 gram of hydrogen occupies about 11 liters of, volume at atmospheric conditions. So therefore, in the form of gas, it might be difficult to store. So if you go for the gaseous storage, you need a very huge tank for storing the hydrogen. But alternately, there are options, like in case of the liquid hydrogen. Yes, here we can store, but the liquefaction temperature of hydrogen is minus 253 Kelvin. So it's very difficult to achieve this temperature. And you cannot use the liquid hydrogen by day-to-day practical application. Then the other option is that you can go for the solid state form using metal hydride. You can store hydrogen in the form of solid state, which is reliable and safe and reasonably economical. That's what we are planning to use, for this, as well as the practical application. So in IIT Guwahati, we have, of course, a very big team, and we have been working on the hydrogen storage for more than a decade, and several students, PhD students, already graduated. And we have several patents and over 150 odd publications we have generated in this technology. And we developed several, the product, and which has been transferred industry like NTPC and many industry. So we are working extensively. We are working on hydrogen purification, the metal and the hydrogen-based thermal storage system, hydrogen-based cooling system, hydrogen compressor, and this all these machines are thermally driven machines. So here the main functional material is the metal hydride. Basically, metal hydrides are the intermetallic compounds, and they can be produced by alloying up different rare earth metals like titanium, lanthanum, and manganese, and etc. So this can be produced either by ball milling or melting route. When this intermetallic alloy exposed to hydrogen at certain temperature and pressure, they absorb huge amount of hydrogen, and during absorption, it will releases the heat. This is the exothermic reaction. And the reverse, when you supply heat to the metal hydride, then the hydrogen will be released from the metal hydride, then by taking the heat. So basically, these two reactions are the absorption of metal hydride, absorption of hydrogen by metal hydride, and desorption of hydrogen from the metal hydride. Both are reversible nature. So by using these two reversible chemical reaction, so you can build several engineering applications. So now you can see here, when you store the metal hydride inside the reactor, it can generate the heat. This heat can be anywhere between 100 to even 200, 300 degrees Celsius, which can be used for several applications. On the other side, when you dissolve the hydrogen from the metal hydride bed, that means when you discharge the hydrogen from the metal hydride bed, it will produce the cooling. Now you can see here, within about roughly about say 2 minutes, you can see the formation of ice over the reactor. Maybe if you allow it, maybe for about a few minutes, and you can see the complete reactor will be filled with ice. So this can be used for several applications, including the cold storage, air conditioning, refrigeration. Many applications can be explored. See, whatever the reactor here you are saving, this can store nearly about 6,000 to 11,000 liters of hydrogen at in very safe condition. And this is, again, you can see here, this is another reactor here. Here also it can store nearly about, here we have mentioned 6,000 liter, but if you go for the better material, this device can store about up to about 11,000 to 12,000 liters of hydrogen. And in addition to that, when you consume the hydrogen from this reactor, which can produce cooling effect roughly about 5 to 7 kilowatt, that means you will get the cooling effect which is close to 210 of AC capacity. Okay, so again the hydrogen purification also, this technology can be used for hydrogen purification as well. Anyway, so even, for example, if you have the purity level of about only 50%, and the remaining maybe CO2 or CO, any impure gas, and you can use our technology, and at the end you can get the high pure hydrogen anywhere between 99 to of course 100%. This technology was transferred to the NTPC. So we developed several such devices for various engineering application, catering from hydrogen, the storage and the hydrogen compression and thermal storage and cooling and heating and even hydrogen purification. So then people think that hydrogen is a dangerous gas, but actually it is not. And there are a couple of experiments have been performed with a similar vehicle. One is the you can see in the right hand side where you can see the flame in a bursting. That is the gasoline, that is petrol vehicle, and another is the hydrogen vehicle. In case of any leakage, in the gas, since hydrogen is having very light, this one density, the hydrogen gas try to move in the upward direction. Even if you set a fire also, the fire will move in the upward direction. So nothing will happen to the vehicle. In case of the petroleum or diesel vehicle, the damage is bulk. So everything will get done. So there won't be any issue. And you can use it in this one. If any accident happens also because of the high diffusivity velocity of hydrogen, it will try to move in the upward direction. So this is the, again, the hydrogen based automobile plant. This is the current status. And so Australia is the world largest producer of hydrogen. Currently, they are producing hydrogen at the rate of about $2.5, and it will be reduced close to maybe about $1.5. That's what they were, promising by 2030. Again, this is from the solar PV route. And in India, of course, most of the hydrogen is produced from the coal reforming, and its cost is about 170 rupees, and natural gas also about 160 rupees. Solar PV seems to be a bit expensive, but when you have excess power generation from the solar PV, and the cost will reduce. And recently there was some announcement from a leading industry from India. They are planning to produce hydrogen at a rate of $1 per kg. If you produce hydrogen by with about $1, so which will make you can major breakthrough in the automobile industry as well as in the manufacturing industry. So the cost will manufacturing industry, particularly the steel mill industry, their cost of this one manufacturing will come down maybe 30 to 40%, even to a larger extent. So the several, the countries came out with, a very interesting plan. For example, UK planning to stop all the IC engine, equipped car automobile by 2025, and stop the usage of all the fossil fuel, based automobile by 2040. And India also will promote the use of electric vehicle, and particularly the hydrogen fuel vehicle by 2030. So beyond 2030, India is also planning to put huge, the tax on the petrol and as well as the diesel vehicle. So the major requirement as per the automobile application is concerned, the refilling time of hydrogen should be less than. Of course, we are working on it. And so as per the fuel cell vehicle is concerned, currently in Japan is the leader, and they have nearly about 1 million vehicles. And South Korea also they have nearly about huge amount of vehicle they have. And China is planning in a major way. So by 2030, they're planning to launch about 10 million hydrogen, the fuel cell based vehicle. And the countries like Germany and South Korea also, they're planning in a big way. So this is the this one. Now we are in the electric vehicle era. So electric vehicle, the battery charger vehicle, yes, this will provide the intermediate solution. But the later, we'll have issue in the battery. Of course, since most of the batteries depends on the lithium, we don't have the resource of lithium. Then if we go for larger use of lithium, then we'll have issue. And so the ultimate goal is to move towards the hydrogen. That is the only this one. Here we can use both the technology. One is the direct hydrogen, combustion, and then that is one route. Another route can be through the fuel cell route. So both the technology can go parallel, and so they have both the technology have its own pros and cons. So maybe by 2030, I'm sure that this technology will boost up, and it will play a major role in the automobile sector and as well as in the industrial sector. So it is predicted that by 2050, the hydrogen on demand will increase 50 times. 50 times. So of course, it is true also the way in which the hydrogen economy is booming. It is definitely will end up with this situation. So therefore, we need to prepare it. So I just before closing my talk, I wanted to give one very interesting project, of course, implemented in Germany. So actually, the German, they have almost 30% of surplus power and generated mostly from the renewables. So in order to safeguard their grid and what they are doing, and they're sending their excess electricity generation to Poland by paying money. In fact, for selling the electricity, Germany is paying money for it. Okay, it's the other way around. Now, of course, a very interesting project has been proposed, and which is very much successful, and they are going to implement the similar project in different parts of the country. So whenever they have excess power generation from the windmill or solar PV or any other renewables, so the excess electricity generator will be converted as hydrogen. The hydrogen will be stored in the form of metal hydride or maybe in the gas. So then later this hydrogen will be used as a fuel for the automobile. So then whenever they need power, then this hydrogen can be, again from the hydrogen, again power can be generated through the fuel cell, or the part of the hydrogen is injected through their national gas grid along with biogas. So it's a kind of a producer gas. This gas is used for several applications, including cooking and heating, etc. So in that way, they are utilizing their excess electricity generator. So since India is also going in a big way, particularly on the renewable energy sector, so whenever you produce excess energy from the renewable sector, where you cannot inject to the grid because of the stability, grid stability, so you can convert the excess electricity into hydrogen, and then can be used as a fuel for the automobile. So therefore, this scenario is going to come very soon, and definitely, of course, we will enjoy you can say the pollution-free and you can say the harmless, you can say environment very soon in the future. So thank you very much. So this is the end of my talk. So if any one of you, if you have any queries or clarification and anything, you are free to ask. Of course, I'm happy to answer your query.
Sir, there is a question for you from Ms. Alpana Tiwari, that this thing is only for commercial users.
Which one you're asking?
So this energy fuel efficiency we can use for the only for the commercial purpose or for the domestic purpose?
Okay, I mean, you are asking about the porous radiant burner.
Yes, sir.
Which can be used for all application. In fact, my first slide was talking about the porous radiant burner developed for the commercial, domestic application. The domestic application, we got about 30% fuel saving. Yeah, so which can be used for domestic cooking, commercial cooking, industrial application, any application you can use it.
Okay.
Yeah.
Our honorable IIM member Shri Goyal Saab also having some query.
Good morning. Good afternoon. I same question from my side. This is your cooking porous radiant burner. Is it for our purpose? Is it available in market or in under research status?
So this is currently it is not available in the market. It is about to be commercialized. And actually there are some burners, actually the surface combustion burners, which also they're claiming as a porous radiant burner. I think they are importing from some countries. Some vendors that are supplying it, but that is not our burner. So our burner is yet to be commercialized, yet to be launched to the market.
Now, what time it will take?
Maybe in 3 months. In 3 months, we are in the final stage, and so we are working out all the production strategy, everything we are working out. Maybe before December, you can see our burner in the commercial market.
And another question is linked with this: how can we judge? My shape is different, or some tag mark is there around this burner? How can we differentiate?
No. But I could not get your questions clearly. Can you say again?
The same present burner we are using now in houses, and your developed burner. How can we differentiate in market? Is there a category or any special?
Okay, fine. So as per my understanding, you are asking how our porous radiant burner is different from conventional burner, isn't it? Yeah. So that I think in the beginning itself I explained because in our burner it utilizes the concept of porous medium technology. Here the predominant mode of heat transfer from the burner surface to the vessel is by radiation. The radiation travels at a speed of light. Okay, so that is the first thing. And the second thing, here we are making the fuel I mean, we are making the fuel to combust 100%. So there won't be any unburned, fuel in our case. So because of the improved heat transfer with the help of the combined mode of conduction and radiation and the complete combustion, we could get the fuel saving up to about 30 to 60%. In case of the conventional burner, the mode of heat transfer from the flame to the vessel is by convection. The convective heat transfer coefficient of air is very low. So the very low convective heat transfer coefficient imposes the heat transfer, imposes penalty on the heat transfer. So as a result, the heat loss to the surroundings will be more.
Okay, okay, good.
Okay. Yeah.
Okay, thank you.
Yeah. Thank you.
So, sir, thank you so much once again. And it was such an engrossing and fruitful learning session about energy efficient and environment friendly porous radiant burner for cooking and industrial application. On behalf of IIMM and Nirvan University, I would like to take this opportunity to conclude this session with the vote of thanks. I like to express my deep gratitude to Pro-President NUJ and Chairman IIMM Dr. Ravi Goel sir, all the dignitaries, and our most valued invited guest, keynote speaker, Professor P. Muthukumar sir. It was such an engrossing and in-depth learning session. Once again, thank you, sir, for gracing with your expertise-based learning. My sincere thanks to Nirvan management team who made this webinar a resounding success through their cooperation. Last but not least, thanks to all who attended our live session on Facebook, YouTube. So be tuned with Nirvan University. Stay tuned for more such captivating sessions with Nirvan University, Jaipur. Thank you once again.
Thank you. Thanks a lot.
Sir, can everyone open their videos so we can have our group photograph, please? Dr. Charu, Arun, please. Pratibha.
No problem. So,
Okay.
yeah. Excellent session, sir.
Yeah. Yeah.
Really
Thank
enjoyed.
you. Yeah. Thank you, Ravi, Professor
Very
Ravi.
impressive.
Thank you.
Good
Yeah,
session.
it's our pleasure. Yeah.
Very
Very
interesting.
informative. And good
Yes.
session.
Right, sir.
And describe by sites. It is useful for after learning. Additional.
Sure. Yeah, I will share it.
And
Thank you very much. Yeah.
good moderation as well. Thank you.
Yeah.
Thank you so much.
Thank
Thank you, everyone.
Thank you.
Okay.
Thank you, sir.